Okay, so the question is, how in the world is data stored in the computer? I mean, how do we store a song or some music in the computer? So how is that done? Well, remember that a computer has a memory and it has a hard drive. So the idea is going to be the same for both of those. But you have to think of the fact that the memory or the hard drive are basically a bunch of on-off switches. Hundreds of billions of on-off switches. By that I mean a switch that can be in only one of two states. Either it's on or it's off. And basically that's what a computer storage is about. It's just billions of such on-off states. And based on that we store data there. So we say that computers store data as bits. And by bit, it's short for what they say binary digit. And binary means 2. So a binary digit means a digit that can only take on one of two values. So usually we denote them by either 0 or 1. It doesn't really matter what you denote them as. The point is that they can only take on one of two values. And that's what we said when we said that there are these on-off switches. So either it's on or it's off. So it's binary. And we can denote on by 1 maybe, and off by 0, or vice versa, it doesn't matter. But anyway, they're only in one of two states, so they can be represented. So each switch can be represented by a binary digit, a 0, 1 digit, or a 0, by a bit. Okay, a bit can take on only two values, 0 or 1. A number may be expressed as a string of bits. So what does that mean? So let's take the number 27. So when we write 27, what do we mean? We mean that there are 2 10s and 7 1s, right? That's what we mean when we write 27. If I wrote 37, I would mean there are 3 10s and 7 1s. So by 27, I mean that it's 2 times 10 and 7 times 1, right? And that's what we mean when we write 27. So I write 2 and 7 here, and I say the 7 is in the 1's place, and 10 to the 0 is what? Is 1. So I can write 1 as 10 to the 0. So the 7 is in the 1's place, and the 2 is in the 10's place. 10 to the first is 10. And if I had a 3 here, what would that mean? 327. 3 hundreds, 2 10s, and 7 1s. So this 3 would be in the hundreds place, or 10 squared place. If I had a number out here like 1327, that would mean 1 1000, 10 to the third. So these are how many of these there are, right? So that's called a decimal number system. The decimal number, deci means decimal, deci comes from the Greek word, I believe it's Greek or Latin. I think it's, well anyway, for 10. So this is, we represent ones, tens, hundreds, thousands, and so on. But we can also represent 27 using this setup here. So instead of 10 to the 0, 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, I can use 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. So what does 11011 mean? So this means, remember this is the 1's place, so this means 1 1, and this is the 2's place because 2 to the first is 2. So 1 2, and this is the 4's place because 2 to the second is 4, so there's 0 4's. And this is the 8's place, so there's 1 8, and this is the 16th place, so there's 1 16th. So if I write 11011, I mean 1 times 16, just like it was 2 times 10. Now it's 1 times 16, 1 times 8, 0 times this, so we won't write that because it's 0. 1 times 2 to the first, and 1 times 1. This is 1. So what do I get? 1 times 16 is 16 plus 8 is 24 plus 2 is 26 plus 1 is 27. So this, when I write it, when I say that it's a binary representation as opposed to a decimal representation, that this is also equal to 27, just like this was equal to 27. Okay, so we can express numbers using a binary representation, just as we can represent numbers using a decimal representation. Now he says, note that there are 8 bits in the binary representation above. What he means by that is, if I read this completely from left to right, there's 1, 2, 3, 4, 5, 6, 7, 8. Now you say, well, I don't need these here. But usually we'll use this whole thing. We'll reserve what we say 8 bits to write a number. Okay. So a byte is called 8 bits. So a grouping. So remember that I said that we have switches in the memory. So billions of switches. So we take groups of 8 of them, and we say, okay, we have one group of 8, another group of 8, another group of 8. We have many, many, many groups of 8. And each group of 8 is called a byte. In other words, a byte is equal to 8 bits. Okay, let's stop here.